I know, guys. You guys are feeling pretty sad because vacation's over. You gotta start watching these videos again and learn math. Wait a minute. Learn math? That's fun. I mean, come on. Really? That's not sad. Here we go. I believe we could just read through this ourselves and review and feel comfortable with this stuff, but there's a couple of things that are different. We've already done all of this. Let's go up here to the new stuff. This is important stuff right here. Factoring sum or difference of two cubes. All right? Yes, we do have to memorize the formulas, okay? So the sum of two cubes formula is whenever you have something cubed plus something cubed, you're going to start by doing a binomial, and it's simply going to be the a plus b inside the binomial, right? Inside the parentheses. And in the other one, you're going to have a squared minus ab plus b squared. I know it looks difficult, but it's actually not that bad. And of course, we have examples right here. It says factor 8x to the third plus 27. So what we need to be able to do first is take the cube root of 8x to the third, because that's the only way we're going to be able to change the whatever this is into just a. So we need to take the cube root of 8x to the third. And what is the cube root of 8x to the third? It is 2x. So in other words, if you rewrite your 8x to the third, if you rewrite it as 2x in parentheses to the third, and the 27 write it as 3 to the third, but the 3 in parentheses, then you'll be able to set it up so you could identify and clearly see a and b. And once you have the a and the b, you're going to be plugging in those a and b values right here into your formula. A right there, b right there, a right there, but you have to square it. A times b right there, and then b right there, but you have to square it. Okay? And that's exactly what we do on the work down here. Okay? So I guess the best way to do this would be to actually see an example. So let's check this out. Let me bring this over. Okay? So this is a binomial, and what we need to be able to do on our own is identify that this is an actual perfect cube term, and this is also a perfect cube term. Now, what if it wasn't a perfect cube term? Then you would not be able to apply the formula, the sum of two cubes, right? By the way, let me just jump back to here real quick. This is the sum of two cubes formula right here. And we already went over that, but there's also the difference of two cubes formula, right? So what's the difference is that they actually have a subtraction symbol. So it's two perfect cube terms being subtracted. So in this case, on this example, we're going to be using the sum of two cubes formula. So let me help you be able to remember how to come up with the formula yourself. So what is the formula? It's when you have something cubed, okay, plus something else cubed, okay, it's going to equal a binomial times a trinomial, okay? Now, the interesting part is that it's going to always start with the same exact two terms that you see, so it's going to be a plus b. So if we have a cubed plus b cubed, it's simply going to be a plus b, right? No cubes on the binomial. Now, the trinomial on the second parentheses that are a little bit bigger, because it's a trinomial, not a binomial, that's where you're going to have a squared, okay? Now, here's the interesting part. If it is a plus, then you're going to have to put a minus, and that'll be a minus ab, and then at the very end, it's going to be a plus b squared. Well, that didn't come out too well. Let me put a different color too right there. Okay, so that's the formula right there, okay? So once again, let me remind you, if you have a cubed plus b cubed, it's simply going to be a plus b in the first one. Guess what? If it's an a cubed minus b cubed, what's it going to be right here? It's going to be an a minus b in the first one, okay? And if this is a plus, then this middle sign over here is going to be the opposite. It's going to be a minus. Guess what? If it's a minus, this middle sign is going to be a plus. So let's say you wanted to write the formula for the difference of two cubes. Let's say a cubed minus b cubed, okay? So how do we do that? It's going to be, again, a binomial times a trinomial. So I do a smaller parenthesis and a bigger parenthesis, right? So what belongs in the binomial, it's going to simply be what you see right here, but without the exponents. It's going to be a minus b. Okay, without the exponents. Same exact binomial, but without the exponents. And now on the bigger set of parentheses, it's going to start out always a squared. And now remember, if the middle term, or if the sign in the original was minus, then the middle term sign has to be the opposite. It's going to be plus, okay? AB. AB is always in the middle. And the last term is always going to be b squared. Now, if you're thinking what belongs in front of the b squared, a plus or a minus, it's always plus. And a good way to remember that is anything squared is always going to be positive. So just remember that'll be positive. Anything squared is always going to be positive. It's true up here also, and it's true over here also. Anything squared is always positive. So it'll help you just remember how to create those formulas. Anyhow, now that we know how to create the formulas from scratch, or memorize the formulas, we could now apply the formulas. So how are we going to do this? Let's first focus in on the sum of two cubes, because that's what we're working with. And we need to be able to rewrite the 64x to the third plus 125 as something cubed plus something cubed. So the 125 is really easy to do if you think about it. What times itself? 3 times gives you 125. That would be 5. Okay, why? Because 5 times 5 is 25, and 25 times 5 gives you 125. How about 64x to the third? You could just go through and make a perfect cube number list if you wanted to. So if you go 2 times 2 times 2, you get 8, not 64. 3 times 3 times 3, you get 27, not 64. But if you go 4 times 4 times 4, you actually do get 64, right? So what I'm going to put in here is going to be a 4x, right? That's the very first thing you need to do, be able to rewrite it like that. Now, this isn't even going to be actually part of your answer. The reason why we rewrite it like that is to clearly identify the a value and the b value that end up in these spots on the formula, okay? So this is what I'm going to do. I'm going to rewrite the formula. I'm going to put a binomial times a trinomial, all right? So here we go. Here's the binomial, and here's the trinomial, okay? Now, what are we going to do? We're going to plug in the a and the b. So instead of a plus b, what am I going to have? I'm going to have a 4x plus 5, okay? And how about over here? This is where it gets a little tricky. A squared, okay? Well, if I'm going to write a squared, I better put the a in parentheses, and the a value in this case is 4x, and then I'm going to put the square on the outside of the parentheses, okay? And then it has a, what else does it have? It has a minus ab. So I'm going to put minus a times b. What is a times b? I'm not going to actually work it out, even though I already know it's 20x. I'm going to write it 4x times 5, okay? And last but not least, let me make this a little bit, see if I could fit it in there. B squared, plus b squared is the last thing that I need on my formula. So let me go plus b squared, and what is b? It's 5, so I'm going to put 5 squared. I mean, I guess I could put it in parentheses, even though I don't really need it. 5 squared is going to be 25 at the end of it all. So let me work through this. Let me work on the trinomial part. That's what I need to work on, because the binomial is already good. 4x plus 5, that's already nice and neat. The trinomial is what I need to work on. What is 4x times 4x? That's 16x squared. And what is a negative 4x times 5, or a minus 4x times 5? It's going to be a minus 20x. And then last but not least, plus 25, because 5 squared is 25. So, ladies and gentlemen, we have factored using the sum of two cubes formula. So let's jump back to our notes over here. And what about our notes? I hope we have a better understanding of sum of two cubes formula and also difference of two cubes formula. Of course, I'll make more videos so you could see more things. But let's go to factoring by grouping. This one's very interesting because what we need to do, the first weird thing is that there's 4 terms, 1, 2, 3, 4. And what we need to do is make 2 groups, all right? So we're going to separate into 2 groups, all right? Separate into 2 groups. So we're going to take the first half and the second half, we're going to leave some space between them. That's the first thing to do, okay? And then what do we do after that, after making it into 2 groups? Out of each group, factor something, okay? So that's what it says here. Factor something out of each group. I know it didn't print that well. It's kind of separated. Factor something out of each group. So if we take a look at the first group, there's x's in both, so we could pull out a greatest x squared, a greatest common factor of x squared. So if you do pull out that x squared, you're going to have an x plus 1 left over on the inside of the parentheses, right? Take out an x squared from there, what's left? Just an x. Take out an x squared from there, there's not going to be anything left, so we put a 1, because x squared times 1 takes you back to the x squared. I hope that makes sense. Now we look at the second group. Is there anything to factor out of there? No, there's not, right? If you really wanted to factor something, I guess you could put a 1 out here that you factored out, a positive 1, but it's not going to really make any difference at all. So I'm going to put the plus 1 just for the sake of doing it. Now after that, what you do is you take a step back and you think, what is in common in my first group and in my second group? Okay, what's in common? And if you take a look carefully, there's the binomial that's in common in both. So the x plus 1 is right there, and the x plus 1 is right there. So if you pull out that x plus 1, think about this. Imagine, okay, this is let's imagine there's a big giant parenthesis around the whole thing. If I pull out and let me put this big giant parenthesis right here. If I pull out the x plus 1, what's going to be left in the whole thing? Whoops, that's the ugliest x I've ever seen. There's going to be an x squared left over and a plus 1 left over. And that's exactly what I have right here. There's the x plus 1 that I factored out, and there's an x squared plus 1 left over. Let's go through and see an example of this. I know it's kind of confusing when I'm just reading it off the notes. Let's go through and see an example of this. Okay, so right here, okay, actually right here I messed up. There's a missing exponent of 2 right there. So if you want, go ahead and write that in if you're copying down notes. Anyhow, right here, let's factor by grouping. Let's first separate it into 2 groups. So we're going to have x to the third minus 2x squared, and then we have the plus 9x minus 18. That's the first step on factoring by grouping. You make 2 groups. Next, we're going to look at the inside of we're going to look at the first group and see what we could factor out. I could factor out a maximum of x squared, right? Because there's at least an x squared in the first term and the second term. What is left over if I pull out an x squared? Well, there's going to be an x left over, and there's going to be a minus 2 left over. Okay, so we factored from the first group. Now let's factor from the second group. What could we factor from the second group? Well, there's a 9x and there's a minus 18, so we could definitely pull out a positive 9, right? And if we do pull out a positive 9, what's going to be left over on the inside? Well, there's going to be an x and a minus 2 left over on the inside, okay? So here's the fun part. You have to take a step back. It's kind of like taking the whole thing and realizing what's in common in the first group and in the second group. Okay, what is in common in the first group and in the second group? If you look at this first group, there's something there that's also in this one, and I put it in blue on purpose. There's an x minus 2 in both. So what I'm going to do is I'm going to put some big parentheses, right? And I'm going to take that x minus 2 and put it out here, x minus 2. Okay, and I'll put that in parentheses also. Now if I do pull out the x minus 2 from the first group, what's going to be left? Just the x squared. If I pull out the x minus 2 from the second group, what's going to be left? Just the plus 9. And that is your answer. Of course, you could write it a lot better, a lot smaller. Let me write it proportionally here. X minus 2, parenthesis, x squared plus 9. And right here, there's nothing else to do. Sometimes you might have like an x squared minus 9, and then you could continue factoring. But right here, that's it. We have factored, and it was something that we weren't able to factor before, but now we are able to factor because of factoring by grouping.